Welcome dear students to lecture 5 of module 3 time response of feedback control systems. Let us work out some more numericals on this topic. So here question is you have to find the step response for the system described by C of S by R of S equal to 4 by S plus 4. Also find the time constant, rise time and the settling time. So first let us write the transfer function. So C of S by R of S equal to 4 divided by S plus 4. Now from here you can observe that this is a first order system. What is the order? Order means the highest power of S or number of closed loop poles in the system. How do you find the closed loop poles? You have to equate the denominator of the closed loop transfer function to 0. So whatever poles you get, that is the order of the system. So here see S plus 4 equal to 0, S equal to minus 4. So you will get only one pole. Hence it is a first order system. So whatever derivation we had done, right, for all these rise time and settling time, that we had done for second order. So that we cannot apply over here. So we have to do this from the basics. So how do we start with the, we have to apply the Laplace inverse and find C of t. That will be the step response. So what is R of S? There was step response. Therefore, R of S is equal to 1 by S. So let us write what is C of S. Let me take R of S to the other side. So we get it as 4 divided by S into S plus 4. Now how do you apply Laplace inverse? We have to use the partial fraction method. So here 4 divided by S into S plus 4. I can write it as A by S plus B by S plus 4. So if I take the common denominator, I get 4 equal to A into S plus 4 plus B into S. Okay. Now what you have to do? You have to substitute S equal to 0. If I substitute S equal to 0, what do we get? A equal to A into 4 we get. So A will be equal to 1. So if I substitute S equal to minus 4, we get 4 is equal to B into minus 4. So I get B as minus 1. Now this let us substitute over in C of S. So A by S, 1 by S. This is minus 1 by S plus 4. Now let us apply Laplace inverse. C of t equal to 1 by S, Laplace inverse is 1, minus 1 by S plus 4, Laplace inverse is e power minus t. So this is the step response. Further, we still have not completed the problem. What is asked? Time constant. So what is the time constant given by? The formula for time constant T is equal to 1 by A. Okay. So here it is A is 1 by 4. That is C. How is the response? It is C of T. Generalized response 1 minus e power minus AT. This is the way the first order response is. So A is got from here. Okay. So it is 4 there. Then what we have? Rise time. So rise time TR is equal to 2.2 by A. That is 2.2 divided by 4. We get it as 0.55 seconds. Next settling time we are supposed to find. So TS equal to 4 by A equal to 4 by 4, which is equal to 1 second. Okay, this derivation is not needed. You can directly, if you know the formulas, it is sufficient. So next question over here is a second order system is given, which is Q of S by I of S equal to 1 by J square plus Fs plus K. A step input of 10 Newton meter is applied to the system and the test results are. So what is given? Maximum overshoot is 6%. Time at peak overshoot, that is TP, is 1 second. Steady state value of the output is zero point 0.5 radian. We have to determine the values of J, F and K. So how do we start with this one? So first thing, as we have done previously, we have to take the transfer function. So Q of S divided by I of S equal to 1 divided by J S square plus Fs plus K. Now we don't want the coefficients with S square, so let us take J outside. So if I take J outside, so Q of S divided by I of S equal to, if I take J outside, it will go to the numerator. So it will be S square plus F by J into S plus K by J. So what is the next step? Next step is comparing with the standard second order transfer function, right? So if what is the second order transfer, I'll just write the denominator. Denominator is S square plus 2 zeta omega ns plus omega n square. So if I compare, we get omega n square is equal to k by j. Always remember, compare only the denominators, never compare the numerator. This is k by j. So omega n will be root k by j. Next, 2 zeta omega n will be equal to f by j. So zeta will be equal to f by j into 2 omega n. F by j into 2 into root k by root j. I can write this as f by c. J I can write as root j 2 root k by root j. So this will cancel. So I'll get zeta as f by 2 root j k we will get. Now let us consider the test results. What are the information you have got from test results? We'll take that. So there percentage MP is given as 6%. So we'll consider this. What's the formula for percentage MP? So 6 equal to e power minus pi zeta by root of 1 minus zeta square into 100. So this will be 0.06 equal to e power minus pi zeta divided by root of 1 minus zeta square. Taking natural log on both sides, what do we get? We get minus 2.813 equal to minus pi zeta by root of 1 minus zeta square. So minus minus will get cancelled out, and let us square both the sides. If I square, get it as 7.915 into 1 minus zeta square equal to pi square zeta square, where pi square zeta square will be 9.87 zeta square. So just 7.915 minus 7.915 zeta square equal to 9.87 zeta square. So get this as 17.785 zeta square equal to 7.915, and zeta square equal to 0.045, hence zeta we get as 0.667. This is how we have calculated zeta. Previous problems also, in the previous lecture also, we have calculated zeta in this way. So let us proceed further. What else is given? TP is given, right? TP, what's the formula? Pi by omega d. What is TP? 1. Pi by omega d. Hence, what do we get here? Omega d is equal to pi, which is equal to 3.142 radians per second. So from omega d, we can get omega n. What's the formula? Omega d equal to omega n root of 1 minus zeta square. So what is omega n? Omega d divided by root of 1 minus zeta square. We get it as 3.142 divided by root of 1 minus 0.667 square, which is equal to 4.22 radians per second. So now we got omega n. Okay, next what is given? We have steady state value is given. So steady state value, I can write it as QSS. Okay, so this, if I take the formula for steady state value, QSS equal to limit S tends to 0, S into Q of S. What is I of S? The input is given. It is given as 10 Newton meter. So it is nothing but a step input. So I can consider it as 10 by S. Therefore, now let us substitute the values. QSS, it is given as 0.5 radians equal to limit S tends to 0, S into, so what is the transfer function? See, I of S will go to the right hand side, so 10 divided by S into the transfer function, right? So 1 by J divided by S square plus F by J into S plus K by J. So here S, this S and this S will cancel. So what we get? 0.5 is equal to 1 by J into 10 divided by K by J. And cancel out J as well. So what do we get? K is equal to, get it as 20. So we got the answer for K. Now let us proceed and find the answer for other two unknowns. So we know omega n is equal to root K by J, right? And we have found the omega n value already. So what is J? So root J will be root K by omega n. So here is root of 20 divided by omega 1 n, we got it as 4.22. So this getting as 1.059 and J will be square of this, so it is 1.123. So we got the J. Next, what is zeta? Zeta is equal to 4f by 2 root J into K. Okay, is equal to, if I substitute over here, yes, zeta value we know it is 0.667 is equal to f we need to find divided by 2 root of J is 1.123 into K is 20. So F is equal to, after simplification, get 6.322. So all the values, whatever we are supposed to find, we have got. J, F and K values are obtained. So next question, referring to the figure, find the following. Transfer function f of x of s by f of s. Second, zeta and omega n. Percentage MP, Ts and T, P where K is equal to 33 Newton per meter, P is 15 Newton second per meter and M is 3 kg. So we have been given a mechanical circuit over here. So first thing is you have to find the transfer function. So how do we find the transfer function? Let us write the equivalent diagram for this. We know how to draw the equivalent diagram, right? We have already done this in module 1. So here this is f of t and here we have the mass connected between the node. Yes, here we can consider the displacement as x of t. So this is x of t node here. And we have k, which is between the node and ground, and also b, which is between node and the ground. Okay. So if I write the equation, so f of t is equal to m d square x by dt square plus b dx by dt plus k into x of t or x. Okay. Now we have to apply the Laplace transform to this. So what do we get? F of s equal to s square m into x of s plus s into b into x of s plus k into x of s. F of s equal to, let me take x of s common, so we get s square m plus s into b plus k. So transfer function is x of s by f of s, which is equal to 1 by s square m plus sb plus k. Now, since we don't want any coefficient with s square, let us take m out. So that will go to the numerator 1 by m divided by s square plus b by m into s plus k by m. Okay, so we have got the transfer function. What is the next step? We have to compare, right? Compare it to the standard second order transfer function. So I'll just consider the denominator s square plus 2 zeta omega n s plus omega n square. So comparing omega n, we get it as omega n square as k by m. Omega n is root k by m. Okay. Here 2 zeta omega n is equal to b by m. So zeta is equal to b by m into 2 omega n. This is b by 2m into omega n is root of k by m. So here this again see m root m root m, if I write 1 root m will cancel, get b 2 root k m. This is zeta. So we have got these values here. Okay, now let us we know no k and m values we know, so we can find. Yeah, so let us find omega n. Since the values are directly given, we can directly substitute. I have just done the derivation there. Okay, the values and all in terms of k and m I wrote. So this will be root 33 by 3, which is equal to 3.317 radians per second. And here zeta is equal to, we got this b 2 root k into m. So here it is, b is 15 divided by 2 root 3 into m. Okay, m value is 3 and k value is 33. So this we get as 0.754. Zeta is 0.754. So next what is asked? We got zeta and omega n. Now percentage ownership. Percentage MP is equal to, we know the formula, e power minus pi zeta, right? E power minus pi. Zeta is 0.754 by root of 1 minus zeta square. 0.754 square into 100. So you simplify this. This will be 2.72%. This is the percentage overshoot. Next, what is our settling time? TS. If it is not given, then we consider it as 2% tolerance and proceed. This is 4 by zeta omega n, which is equal to 4 divided by zeta 0.754 into 3.317. This is equal to 1.59 second. So next, what is remaining? The peak hour time. Peak time. Okay, peak time TP is equal to pi by omega d. It is pi divided by omega d is omega n root of 1 minus zeta square. So this is pi divided by omega n is 3.317 root of 1 minus 0.754 square. So we get this as 1.44 second. So we have found all the necessary things what is asked in the question. So next question is, a system is given by the differential equation d square y by dt square plus 4dy by dt plus 8y is equal to 8x, where y is output, x is input. Determine peak overshoot, settling time, peak time for unit step input. See, whenever the time response specifications are asked, first thing is you need a closed loop transfer function. So here differential equation is given. Let us find the closed loop transfer function. Let me write the differential equation given. So it is d square y by dt square plus 4 dy by dt plus 8y is equal to 8x. So what you have to do, you have to apply Laplace for this. So d square will be s square into y of s plus 4 into s into y of s plus 8 into y of s equal to 8 into x of s. Let me take all y of s terms common here. S square plus 4s plus 8 equal to 8x of s. And see, they mentioned there y is the output, x is the input. Therefore, transfer function will be y of s by x of s. This is a closed loop transfer function. Get it as 8 divided by s square plus 4s plus 8. Okay. What is the next step? By now, I think you are very well aware what is the next step, right? Next step is what? Comparing with the standard second order transfer function. So, I'll just write the denominator s square plus 2 zeta omega n s plus omega n square. Okay. So, if I compare this, what do we get? Omega n is equal to omega n square equal 8, or omega n is equal to root 8 radians per second. 2 zeta omega n will be equal to 4. So what is zeta? 4 divided by 2 root 8. So calculate this using calculator. It's 0.707 is the zeta. So percentage MP. Then maximum overshoot is as peak overshoot is e power minus pi. Zeta is 0.707 divided by root of 1 minus 0.707 square into 100. Okay, so again simple calculator. Okay, 4.83%. All these are very simple direct calculations. Then settling time. Nothing is given. 2% tolerance. 4 by zeta omega n, which is equal to 4 divided by 0.707 into root 8. This is equal to 2 second. Then next, what is asked further? After Ts, yes, peak time Tp is equal to pi by omega d. Pi by, what is omega d? Omega n root of 1 minus zeta square. So here pi divided by omega n is root 8. Simplified and write, or root 8 you write, no issues. Okay. So 1 minus 0.707 square. So this will be 1.57 seconds dp. So we have finished the problem. So here next question is, a unity feedback system is characterized by an open loop transfer function g of s equal to k by s into s plus 10. Determine the gain k so that the system will have a damping ratio of 0.5. For this value of k, determine the settling time, peak overshoot and time to peak overshoot for step input. So again, as usual, first step is finding the closed loop transfer function g of s by r of s. So g of s is given, right? K divided by s into s plus 10. This is g of s. What is h of s? It is mentioned that it is unity feedback. So what's the formula for g of s by r of s? G of s by 1 plus g of s h of s. So 1 plus again k. This is g of s, k divided by s into s plus 10, and h of s is 1. So after simplification you get it as k divided by s square plus 10s plus k. This is the closed loop transfer function. Right? Next step, comparing. Yes, by now everybody is aware what you're supposed to do after what. So omega n square will be equal to k, and omega n is equal to root k. Next, 2 zeta omega n is equal to 10 we get. So omega n, now we know zeta, right? So we can find omega n from here. 10 divided by 2 into zeta is given in the question. So zeta is given as 0.5. It is mentioned there. Okay, damping ratio. So we get omega n as 10 over here. So what is k? K is omega n square. So this is 10 square, which is equal to 100. So k we get it as 100. Then what is asked? For this value of k, we need to find the settling time. So what is settling time Ts? 4 by zeta omega n. So that is 4 divided by zeta is 0.5 and omega n is 10. So this we get as 0.8 second. Next, the peak overshoot is asked. So peak overshoot is percentage MP, which is equal to e power minus pi. Zeta is 0.5, which is given, divided by root of 1 minus 0.5 square into 100. Use your calculator, you get this as 16.3% percentage MP. Next, the peak time. Tp is equal to pi by omega d, which is equal to pi by omega n root of 1 minus zeta square. Pi by omega n is 10 root of 1 minus 0.5 square. So we get this as 0.363 second. So next question is, the response of a servo mechanism is given by C of t equal 1 plus 0.2 e power minus 60t minus 1.2 e power minus 10t when subjected to a unit step input. So obtain the expression for closed loop transfer function and determine the undamped natural frequency. So first step is finding the transfer function. So what is given? The step response is given. C of t equal to 1 plus 0.2 e power minus 60t minus 1.2 e power minus 10t. So this is in time domain. We need the transfer function. So C of S equal to applying Laplace. So 1 is 1 by S plus 0.2. Laplace transform of e power minus 80 is 1 by S plus a, right? So this is 1 by S plus 60 minus 1.2. E power minus 10t will be 1 by S plus 10. Alright. So now what are we supposed to do? Let us take the common denominator over here. So you can write this as S into S plus 60 into S plus 10. So this will be S in, sorry, not S, 1. No, it is here S. This is 1 into S plus 60 into S plus 10 plus 0.2 into S plus 10 minus 1.2 into S plus 60. Right? Open up the bracket, solve this. So numerator we are going to get as 600 divided by S into S plus 60 into S plus 10. This is C of S. We know it is unity feedback, it is unit step inputs. R of S is 1 by S. So if I take this C of S by R of S, if I take, and if I divide this by 1 by S, so what do we get? That Sn, so here S into S plus 60 into S plus 10. Okay. So this whole of this divided by 1 by S if I take, this will go to the numerator. So S and S will get cancelled. So what we get? 60 divided by S plus 60 into S plus 10. This is what we get. So C of S by R of S is 60 divided by S plus 60 into S plus 10. Right? So now from this, if I further just multiply this and say 60 divided by, so get as 6 square plus 70s plus 600. So what is asked? Undamped natural frequency. What is undamped? Undamped natural frequency. So So that is given by omega n. How do you get omega n? Comparing the with the second order transform. So omega n square is equal to 600. So what is omega n? It is 24.49 radians per second. This is the answer.